Hey, today we're going to talk about what's in this bottle. It might look empty, but it's full, and I'm going to prove it to you. I promise this is going to make sense, but right now I'm just proving to you that I'm not incompetent. Now I'm going to put this balloon in the bottle. We decided it was full, right? Here we go. Now that it's in the bottle, let me just seal it. I'm going to blow this balloon up again. Ready? I can't blow it up because the bottle is full. It's almost like there's something in here pushing against that balloon. But let's try it with more power. So I'm just going to put a seal on here. All right, you ready? Did you see that? Even though we had a bike pump, we still couldn't fill the bottle with the balloon. Why? Because the bottle was full. What's it full of? Air, of course. Gases are compressible, as we know. And so my lung power wasn't enough to compress the air inside of here very much. The bike pump did a little bit better, but overall there was too much air in here to fill it with a balloon. So, just how much air is there in this bottle?
Because the bottle is full of gas at room temperature, atmospheric pressure, it's going to behave like an ideal gas, which means we can determine how much gas is in there by using the ideal gas law. When we say how much is there, we're referring to the moles. If we want to know how many moles of gas there are, then we need to know these other pieces of information. What's the pressure, what's the volume, and what's the temperature. Remember that R is a constant, so it will never change. The pressure is going to be 1 atmosphere, roughly, because there aren't any hills to speak of, and there's certainly no mountains, so everywhere is about sea level, which is 1 atmosphere. The volume we can find by measuring the dimensions of the bottle, and the temperature we can measure by the room. Room temperature is about 298 Kelvin or 25 degrees Celsius, so we'll go with that value for the temperature of the room. The volume, the bottle is a cylinder, so in this direction I measured it to be 24 centimeters. The radius I measured to be 3.8 centimeters, so we can use the volume of a cylinder and calculate that it is 1100 centimeters cubed. Because the R is usually in units of atmosphere liters per mole Kelvin, let's turn that into liters. Remember, a centimeter cubed is the same as a milliliter, so then we can divide by 1,000, and we have the volume as 1.1 liters. Now we're ready to determine how many moles of air were actually in our bottle. Let's rearrange the equation to solve for n. So that means we'll divide both sides by R and T. Now let's plug in our values. The pressure we said was 1 atmosphere. The volume was 1.1 liters. R is 0.08206 atmosphere liters per mole Kelvin. And the temperature, 298 Kelvin. That means that there is 0.04498 moles of air in the bottle. Now here it gets a little complicated because air is made up of nitrogen, oxygen, and some other various things, including carbon dioxide, argon, etc., etc. So if you want to figure out, let's say, how much that air weighed, you could use Dalton's law of partial pressures to determine how much it is. But let's just calculate how much it weighs based on the nitrogen. We can just use the molar mass of nitrogen because nitrogen composes about 78% of air and oxygen is 21%, and then everything else is roughly 1%. So nitrogen will have the biggest effect on the overall mass, and nitrogen and oxygen are very similar in their molar mass, and together they account for 99% of what's in the air. So that is a good approximation for us. We want to convert the moles into grams, and we can use the molar mass of nitrogen here. This will be a little bit low because oxygen weighs a little bit more per mole, and carbon dioxide, argon, the other things in the air also weigh a little bit more. So it'd be 1.3 grams of air. So the reason why we think it feels empty is because the air in that whole bottle weighs about the same as a paper clip, so we don't notice it, But when you test it, you can see that it is still taking up space and it is still matter.
And that's it for this edition of Chemistry in Real Life.